Our universe, the cosmos, is richly filled with galaxies, dust, gases, radiation, and more. All of this we can observe. But science, cosmology, heavily relies on mathematical calculations, often on speculations. For example, our universe is said to have originated from a Big Bang. As depicted in this animation. The expanding yellow spot in this animation is a simplified representation of our universe. The idea of a Big Bang, a cosmic explosion, is derived from the expansion of our universe. Redshift in the light from distant galaxies is an indication of this expansion. Observable cosmic background radiation is considered the light of the universe shortly after the Big Bang. However, the expansion, as we seem to observe it, is less certain than generally believed. Further elaboration on this will be provided at the end of this video. As the universe expanded, it cooled down, as illustrated in this animation by the shift towards blue. The scientific community is divided on whether the universe will ever contract again, a scenario known as the Big Crunch. The prevailing scientific view is that this contraction will not happen, largely due to the presence of a mysterious dark energy that is thought to prevent it. But is that truly the case? Could a Big Crunch still occur, as depicted in this animation? Let's envision the universe as a cube and as a moment in time. But time progresses. Billions of years later, there is still a universe. But it's different. This second cube in the animation represents our universe at that later moment. Now, we connect the corners of our universe with timelines. What we see now is a hypercube, a four-dimensional cube where time is considered the fourth dimension. The hypercube is bounded by 8 three-dimensional cubes. Let's take a look at those. This two-dimensional representation is somewhat distorted. However, when rotated, it becomes clear that all shapes are cubes. Now, let's examine the passage of time. The green cube represents the current cosmos. It moves through time. In this simplified animation, we don't consider the expansion and contraction of the universe. For a better understanding of the cosmic model in this video, we need to examine wave patterns. Let's take the electromagnetic wave pattern as an example. Electric and magnetic forces in wave patterns are entangled. They always go together. The magnetic field is generated by a change in the electric field. Conversely, the electric field is generated by a change in the magnetic field. The light we see is nothing more than the capture of such an electromagnetic wave pattern. For now, let's focus on waves in general. Initially, scientists assumed that waves always propagate through a medium. For water waves, water is the medium. For sound, it's air. For electromagnetic waves, an ether was assumed to be the medium. Even today there are still supporters of a medium for electromagnetic waves. But after James Clerk Maxwell's work in 1864, the mainstream scientific perspective changed. Einstein's theory of relativity also doesn't align well with the idea of an ether as a medium. Nevertheless, it's important to note that consensus in science often eludes us, especially in cosmology. This leaves room for creative thinking. For instance, British scientist Roger Penrose posits that the universe is cyclical. According to his theory, all matter eventually disappears into black holes. These black holes eventually leak out, according to another theory. This is what we call Hawking radiation. It's a quantum mechanical process we won't delve into further here. But ultimately, there's room for a fresh start. Another Big Bang, repeating in a cyclical process. The theory introduced in this video bears some resemblance to Penrose's theory. However, we stay closer to home and connect with more classical physics. We place this cyclical universe within a wave pattern. Thus, we depart from the theory that our universe will endlessly expand. We momentarily black out our screen, contemplating the phenomenon of dark matter. Many cosmological phenomena can't be explained without assuming something like dark matter. For example, the rotation speed of galaxies is greater than calculations based on visible mass allow. There must be more than we can see to hold galaxies together. For this extra, the existence of dark matter is posited. This reconciled the calculations. A A similar situation arose when the previously mentioned dark energy was introduced in science. But whether dark matter and energy actually exist and what they are remains a subject of speculation. In the further course of this video, we'll contribute to this discussion. We return to our animation of the expanding and contracting universe. It doesn't take much imagination to see the periodic expansion and contraction as a wave pattern. So, let's add the wave pattern to our animation. Wave patterns display the world around us and other language of the universe. We know waves of very different lengths. In the small, about 1.616 times 10 to the power of minus 35 meters. The Planck length. In lengths of thousands of kilometers, for example, when it comes to gravitational waves. There's no length limit. We lack the velocity component needed to calculate the universe's wavelength. But if we were to unroll the universe over a timeline, we'd be talking about 280 billion light-years. Let's also take a look at a composite wave, similar to electromagnetism. This is a better candidate for the undulating universe, considering the many unexplained forces. But if our universe is part of an entangled wave pattern, there must also be a paired universe. Just as a dynamic magnetic field is paired with an electric field. We can see this again in the animation. The displayed waves represent the entangled force fields. But now, they are the force fields generating two paired pulsating universes. Illustrated here on the undulating force fields for clarity. We alternately see the two pulsating universes, both alternating from positive to negative and vice versa. There is still an issue in the theory presented here. A force field is not the same as a collection of physical objects. Thus, the universe can't be explained merely from a pulsating force field. Especially if we assume a one-way street, an irreversible expansion. The theory proposed in this video implies that there must be contraction at some point. Contraction in which the spatial distribution of existing energy is reduced. According to the famous formula E equals mc squared, this will ultimately lead to mass formation. The required energy is supplied by the pulsating entangled force field. The Big Bang of one universe provides the energy for the contraction and mass formation of the other. This is as shown in the animation here. Earlier in this video, it was noted that the current expansion of our universe isn't as certain as often believed. What is this bold claim based on? Let's imagine a one-dimensional world. Represented here by the vertical red line. We also assume that time is an additional real dimension. The one-dimensional inhabitant experiences the effects of time but remains bound to moments. Exactly as we saw in an earlier animation of the cosmos shifting in time. But light requires a different approach. The interweaving of light and time suggests that light also travels through the time dimension. Now we emit light from a fixed location using a sodium lamp through our one-dimensional world. A one-dimensional scientist examines the beam for deviations like redshift. He notes here that the spectral lines still match the wavelength of sodium light. But now, imagine the one-dimensional world of the scientist is curved. We can see this in the animation. Now, the scientist in his one-dimensional world will measure a longer wavelength for sodium light. The farther he is from the light source, the greater the redshift he measures. Let's imagine spacetime as spherical. Not a strange thought, even Einstein imagined it that way. For this animation we again subtract 2 dimensions from spacetime. Our one-dimensional world is now curved into a circle. The light moves through a 2-dimensional spacetime with a holographic projection on the curve. Here too, with an increase in distance from the light source, a more pronounced redshift is observed. But this applies only to the one-dimensional observer. The curvature of his world causes a divergent perception of time. In this context, the 2-dimensional holographic projection causes the wavelength distortion, just as a 3-dimensional cube is distorted in a 2-dimensional representation. something quite distinct from redshift due to the source's receding. We've returned to our pulsating universe. With the explanation of the redshift of distant objects, now a more comprehensible concept. The presence of mass alongside pure energy now even makes an imminent Big Crunch plausible. The opposite of what is commonly assumed. In such a scenario, all energy within the universe ultimately transforms into mass according to the formula E equals mc squared. The energy source for this is the Big Bang in the paired universe, the entangled force field. The theory presented in this video does not rely on extensive scientific research. It's merely a fundamentally different approach to what we can observe in the universe. Upon confirmation, many assumptions from a different perspective will need to be re-evaluated. But even from this newly launched theory, numerous new research areas open up. For instance, where can we find sufficiently compressed energy for mass formation? Are there hotspots or still unexplained force fields that could lead to mass formation sooner? To what extent do uncertainties and quanta play a role in the uneven distribution of mass? And so forth.